Professor Kazem has a BS in mining engineer from Staffordshire, and an MS and a PhD in mining engineer from Stirling University, and a BS in mathematics from Stirling University. He is taught in and researches in mining, economics, and underground mining. As I said, at Stirling University. I really don't think he's Scottish, though. Just saying. He's trying to compete with Sid over here. He's written 12 books, 200 papers. He has supervised 70 PhDs and MS projects. Professor Oraee.
Thank you very much, Mr. Chairman. Just bear with me for another 15 minutes or so. The very last paper of the conference, but they do say that they leave the best to the last. Please. Now we are going to talk this time about something which is slightly different, although it is pillar again. Ground control and pillar, of course. What keeps the ground is the pillars, but slightly different. The crown pillar between open cast and underground mining, and especially in this case, blockchain. But it's a slightly different from the previous ones. Determination of the outline, introduction, dimensional analysis, which is what we are going to use to calculate the optimum thickness of the crown pillar, modeling, and then conclusions. There are many mines which are going to have to change from open cast to underground mining soon, in the next years or few decades. And the reasons are, most important reasons are that the depths are increasing, therefore they are becoming more and more expensive. And secondly, the recent reason, the relatively recent reasons is the environmental requirements. That we all know, open cast mines have much more environmental effects than underground mines. And when that happens to any mine, any open cast mine, the first methods that they will have to consider will have to be caving methods. The reason why they don't like the open cast mining companies, don't like changing into underground mining, obviously, is that the costs of underground mining are expected or thought to be higher. But there is one underground method in particular, that is the block caving method, whose costs are comparable with surface mining, especially when the surface mining, the pits become deeper. In such cases, where there is an open cast mine, and the rest of the deposit is going to have to be mined by underground mining, there is a crown pillar required to be left. And what we want to do is to find the thickness of this crown pillar. The main duties or the main requirements of these crown pillars are to provide ground control, just like all other pillars, to provide ground control for the mine, both for the surface and for the underground mine, to minimize interference between the two mines, very important. I don't want to emphasize on these, you all know, everybody has talked about that, and to prevent, particularly in this case, to prevent the entering of underground, entering water from to the underground mine from the surface. Again, as we know, when pits, surface, open cast pits become deeper, the problem of water increases. and we don't want this water to seep into underground mine. And finally, particularly in this case, to confine caving forces within the block to encourage caving to begin. In block caving, this is one of the biggest worries of mining design engineers when they decide to work block caving and when they are planning block caving blocks. That in case they design the block, they derive all the roadways, so many of them, develop all the roadways underneath the block, and that which could take many months or even years, and a lot of money is spent on driving these roadways and maintaining them, and then the block or the ore inside the block does not start to cave. I always say to my students that if it doesn't start to cave, all we can do is sit down in one of those tunnels and pray. And just although if our prayers are not answered and the caving doesn't start, we do have some other remedial actions. One of them is to confine the caving forces within the block. And this particular crown pillar does help that to happen. One of the remedial actions. There are generally three possibilities in these cases: surface mining before underground mining, simultaneous mining in both, and underground mining before surface. In the second and third, of course, the crown pillar is totally necessary. Even in the first one, it can be said that it is necessary to leave a crown pillar. This is just a picture. The top part is the open pit, conical shape, of course. Then transition depth. That is the depth at which the cost of mining each ton of ore is the same for underground and the same as underground and surface mining. And below that depth, of course, is cheaper to mine the ore in underground by underground methods. In this case, by block caving. Determination of the optimal thickness of a crown pillar in a combined mining method using open pit and block caving. I stress in this paper, we are assuming that the underground method that we are going to use is going to be block caving, because the formula which is going to be produced will be different. If we had decided to use shrinkage or cut and fill or supplemental stopping or even self-replicating. This problem or this challenge of the determination of the optimal thickness, we say, is an interesting decision, and it is important. It is interesting because it's relatively new, and it's important because leaving a pillar with optimal thickness will minimize detrimental effects or detrimental interference between the two working areas, whilst maximizing ore recovery. If it is too thin, it has detrimental effects. If it is too thick, we have reduced our recovery. Methodology. In this paper, a formula is established by using the available methods for surface crown pillars. We do have methods for surface crown pillars. Consideration of the effective parameters is the basis of determinations. This has been done by dimensional analysis. This is the method that we are going to use, dimensional analysis. The established formula can be used as a useful tool in all similar mining situations by the mining design engineer to calculate the optimal crown pillar thickness. dimensional analysis is a technique for restructuring the original dimensional variables of a problem into a set of dimensionless products using the constraints imposed upon them by their dimensions. This is the definition of the dimensional analysis. There are two main systems, mass system and force system, which are, in mass systems, we have mass, length and time, and in force system, we have force, length and time. In this paper, we are going to use the force system. Any other physical unit is regarded as a derived unit, since it can be represented by a combination of these three main units. Each base unit represents a dimension. And the modeling procedure. First of all, we'll have to find the most important determinants. We have to find the most important factors which affect the thickness of the